Hello everyone, my name is Samuel Schulter and I'm going to present our work called OmniLabel, a challenging benchmark for language-based object detection. This is a collaboration between NEC Laboratories America and Rutgers University. I assume all of you know what object detection is, the task of localizing and classifying all objects in the image. But what does all objects really mean? Datasets like COCO, Object365, or BDD100K all define a different label space of object categories. And therefore, standard object detectors operate on a fixed label space. Now, generalizing this setting to an open vocabulary has been a hot topic in the past few years. The main goal is to detect novel categories that have not been annotated with bounding boxes in the training data. Most current methods do this by leveraging image caption datasets. However, most benchmarks in this setting still use simple category names to describe objects. These were just not part of the bounding box ground truth. On the other hand, the task of referring expression comprehension has the goal of localizing objects that are referred to by free-form text. Compared to other detection tasks, the object descriptions are more complex than simple category names. The example here is person wearing red sneakers. However, existing benchmarks for this task are often limited in various aspects. For example, the object description always refers to exactly one object in the image. And while there have surely been other detection settings, the goal of our proposed work, OmniLabel, is to set up a task and benchmark that subsumes standard object detection, open vocabulary detection, and referring expression comprehension. So here are the key properties of our new benchmark. First, the label space consists of simple categories like in standard object detection, but it also contains novel categories like in open vocabulary detection, and it also contains more complex object descriptions like referring expressions. The second point is that some of the object descriptions are negatives. This is the default in standard object detection, where not all categories are contained in all images, like the class elephant in this example. But what is new in our benchmark are the free-form object descriptions that are related to the image but do not refer to any object, like blue car in this image. Third, object descriptions can refer to not only a single, but multiple objects in the scene, like a person wearing sunglasses. Now let's compare the OmniLabel benchmark to existing ones. Let's start with a simple feature. We have a sizable number of test images. And although the object detection in the wild benchmark has more images, it does not provide free-form text to describe objects. The descriptions of our benchmark are diverse, with around 4.6 thousand unique nouns. OmniLabel annotates multiple instances per object description, just like in standard object detection, but this is not a common feature in referring expression datasets. And finally, one key contribution of our dataset are negative descriptions, which are also standard in detection benchmarks, but are not in referring expression datasets. Now let's look at some example annotations of our dataset. For each example, we show one positive description along with the ground truth bounding boxes, and also one negative description. We can illustrate here two key aspects of our benchmark and dataset collection. The negative description in this example is wooden bench, which is related to the image because there is a bench, but it's not wooden. And in this last example, the positive description states sandwich with cucumber on it. With our annotation pipeline, we ensured that there are also sandwiches in the image without a cucumber on it, which then requires any model to look at all the words in the object description. At this point, I also want to advertise not only our paper, but this generalized object detection task more broadly. And I'm saying this because this is currently a hot topic. There are 4 concurrent benchmarks that all share similar ideas and features, so check them out. But also make sure you evaluate your language-based detector on our OmniLabel benchmark. It's really easy. Download our dataset from omnilabel.org, get our evaluation code from GitHub, and benchmark your method on a public leaderboard and compare against the winners of the OmniLabel Challenge 2023. Finally, I want to say a big thank you for your attention first of all, but also to all collaborators of this whole project. Thank you.